Okay, so in 6.3 we shift gears just a little bit, but we're still doing confidence intervals. The easy part is we go back to the z distribution. When we do confidence intervals for a proportion, we use the z distribution again, so we don't have to deal with the nuances of the t distribution. So first one here, just real basic terminology here. When we're talking about a point estimate, we're talking about our sample. So in this particular sample, they had 447 that were confident out of the 1578. So we just take 447 divided by the 1578. And we get 0.2833. So that would be 0.283. Okay, so it's just a sample proportion out of our sample size that we calculated. So if our point estimate for p hat is 0.283, q hat is just 1 minus that. So if you want to use your calculator for that, 1 minus 0.283, pretty simple. But we see those two values pop up in our formula, so 0.717. Go. So I'm going to jump to number 6 just to see something a little bit different in this homework assignment. Okay, margin of error. So margin of error is still pretty similar to the last chapter. What happens here when we make a confidence interval is we take our p hat, our point estimate, that's a p hat, plus or minus z star times p hat times q hat all over n. So what's our margin of error? It's this. Instead of just, it's a little bit bigger formula, but it's on your formula sheet, so it's nothing that we have to memorize. So first thing we need to do is figure out what that z star is going to be. Or actually we don't. We have the interval, right? So we do the same thing that we did in the previous section here. I take 0.789. I'll actually get it right this time. I'm going to subtract, right, the larger from the smaller. 0.789 minus 0.763. So that's the length of the interval. And we just divide it by 2. That'll give us our width, which is also our margin of error, 0.013. So when they give us the 2 endpoints of the interval, margin of error, super easy to go ahead and get. What is p hat? P hat lives right in the middle of these two. So all I have to do here, just like x bar in the previous section, is instead of subtracting the 2 of them and dividing by 2, we add the 2 of them and divide by 2. P hat lives right in the middle of the interval, so it's got to be the median of the 2. So that would be 0.776. So let me hop over to number 8. Maybe that one looks a little bit different. Okay, so here we're going to do a full tilt 90% confidence interval. So I want you to see what that looks like on the calculator. So the same area that we've been living in, we've been going to stat and test all this week. And we want to find the 1 proportion z interval. It's a little bit of ways down. Okay, we're dealing with proportions. So I know we did z interval for means. Well, this is a 1 proportion z interval, so we're using z again. But when we're dealing in the economy of proportions, make sure you select the 1 proportion z interval. We only use that t distribution for means. So the x here is the 1,309 that said they made a New Year's resolution. Okay. Our n is our sample size, 2,227. Okay, and our confidence level, we're going to do both. We're going to do 0.9, and I think I showed you this in the last section, and we'll do 0.95. It'll be real easy for us. So for p to 3 decimal places, we can see it right here. Oops. 0.571. And then for the second one to 3 decimal places, 0.605. Okay. And now for 95%, it's going to be real easy because when I do my stat test now, and I go and find my 1 proportion z interval, what's going to happen here, everything's in there. All I have to do is change the 0.9 to 0.95. So I got 0.567. And 0.608. Okay, so it's worth noting, and we talked about this from the start with confidence intervals, the 95% interval is wider than the 90%, right? We're more confident, so we need a wider interval to cast that inference. Right? So I'm going to jump ahead now to 13. Yes, I want to leave that question. Okay, so here's one where we have two things happening. One is where we want to find the minimum sample size when there's no preliminary estimate. Then we have a preliminary estimate of 20%. So a lot of this is exercise in algebra. Okay, for 90% confidence, the z-star is going to be the same every time. We're basically dealing with this formula right here. Okay, and we want this margin of error to be a particular value. We'll have z-star. If we have no estimate, I'll show you how to deal with that. If we do have an estimate, we plug it in there, and we're solving for n. That is what is unknown. Okay, so let's unpack this. See what they're asking us for. So we want 90% confidence. So I know that my z-star is going to be 1.645. How do I know that? Well, I can look it up on a table. Maybe you've seen it enough times now that you remember it, but we would do second bars, and we would inverse norm. If I want 90% in the interval, then the area to the left is 95. Remember, if there's 90% in the interval, then there's 5% in each tail. So I get 1.645 is the critical value for that. So that's the number I'm going to use for my z-stars, 1.645. She wants her confidence interval, or her margin of error, to be 5%. Okay. First part, it says no preliminary estimate. So let me show you what that looks like. If we have no preliminary estimate, we want the margin of error to be 0.05. We know that z-star is 1.645. If I have no preliminary estimate, then I'm going to just use 0.5. That's going to give me the biggest possible sample size. And n is unknown. Okay, so it's z-star, p hat, q hat, over n. We got to solve for this n. So first thing I got to do to get this n by itself is divide both sides by 1.645. This is all algebra here. I'm sure you've all been missing algebra. Okay, so 0.5 times 0.5 is 0.25. How do we get this n? Well, the first thing we have to do is get rid of that radical. So I'm going to square both sides. So if I square this side, then what's left over here is just 0.25 over n. And my next step, this is the way I explain it. If 20 divided by 10 is equal to 2, then for sure 20 divided by 2, if I switch those out, is equal to 10. So that's what I'm going to do. I'm going to take this n, I'm going to switch it with these two. So I can just simply say that n is equal to 0.25 divided by 0.05 over 1.645 squared. And we'll let the calculator do the work from there. Okay, and oops, too many squares happening here. I think that's what I like there. So I get 270.6. I'm going to have to round that up. I can't take a sample size of 270.6. It's going to have to be 271. Okay. Now, what happens if this is now 20%? Real simple fix. Not a lot changes in what we just did, except for this initial step here. Instead of this being 0.5 times 0.5, this is going to be 0.2 times 0.8, okay, which is 0.16. So all the way through that will follow me. This will be 0.16, right? This will then be 0.16, and this will be 0.16. That's all I have to change there, okay? If I have a preliminary estimate of 0.2, then P hat is 0.2, and Q hat is 0.8. So we can make our lives easier by just hitting second enter, and I can change that 0.25 to 0.16. And I get 173.1. Again, I can't take 173.1 or 0.2. If I round that down, though, then my margin of error is going to increase, so I have to always round that up. So I'm going to have to go back up to 174. I know that's not your traditional rounding rule, but you have to round it not to the nearest whole integer, but always round it up to the next largest one. Okay. Okay, so let's take a look at this one, a little bit different than what we've been looking at here. All right, so construct a 99% confidence interval for population proportion of adults who say national identity is strongly tied to birthplace for each country listed. So we've got to do a whole bunch of confidence intervals here. All right, and all we have is the percentages and then the totals. So there were 1,014 adults from country A, and they gave us our P hat of 36%. So how do we reconcile that? Well, if I want to do the confidence interval for proportion, I go to stat, I still go to test, and I still go to my 1 proportion z interval. But they're not telling me you have this number out of that number, so it's a little tricky, right? What they tell me is that I have 36% out of 1,014. So I'm going to take 0.36 times 1,014. Okay, and this is 1,014. Now the problem is the calculator is going to be totally confused when you tell them that you have 365.04 successes. It makes no sense. So round that to 365. Okay, in that case you're definitely going to round to the nearest whole number, because that's going to give you your 365 out of 1,014. That's 36%. That's what we're going for. And what we're doing each time here is a 99% confidence interval. So this is going to be 0.99. And then we go. All right, so I get 0.321. Up to 0.399. Okay, I'm going to do it again, okay, except this time I've got 20% out of 1,016, so I'll show you one more time. Stat, test, 1 proportion z interval. So what do we have now? 20% out of 1,016 from country B. So 0.2 times 1,016. And that's out of 1,016. But remember, the calculator is going to give you an error if you don't round that to the nearest whole number. It has to make sense to it. But we're still living with 99% confidence. So I get 0.167. 0.232, 0.232. Okay, and you just have to do it 3 more times. Country C, country B, country A, same thing, repeating.